We are dealing with the ninth problem in this series, and the ninth problem in this series is problem 3.27. The problem is stating a space is filled up with a charge with volume density rho equals rho naught e to the power minus alpha r cube, where rho naught and alpha are positive constants. R is the distance from the center of the system. Find the magnitude of the electric field strength as a function of R. Investigate the obtained expression for the small and large values of R, that is for alpha r cube less than 1 and alpha r cube greater than 1. So we need to understand that this is talking about a space which is filled with a volume density rho. So we begin by constructing a spherical distribution of the charge arrangement which is discussed in the problem, and at a distance r we consider a patch of thickness dr. So we consider a patch of thickness dr surrounding this region of radius r. So this is the patch we are referring to. So at a distance r we select this patch of thickness dr, and over here the problem is stating that the charge density is equal to rho equals rho naught e to the power minus alpha r cube. So if I consider the elemental volume, so the elemental volume that we have, which we consider as dV, equals 4 pi r square dr, and therefore if I calculate the charge dq, then dq is equal to rho dV. So from here we obtain the expression as rho naught 4 pi r square e to the power minus alpha r cube dr. So since the charge density is given in terms of radius r, so that is why we are considering a spherical distribution of charge. So over here if we integrate this expression for a distance r, we will get the enclosed charge in this region. So from a region of radius r equals zero to a distance r, we will get the enclosed charge in this region, and on solving this integral we obtain the value of enclosed charge as 4 pi rho naught by 3 alpha 1 minus e to the power minus alpha r cube. So this is the expression that we obtain, and a very important part for this problem. Now the question is asking us to calculate the magnitude of electric field strength as a function r. So if we apply Gauss law from this point, so we can say using Gauss law, so if we use Gauss law, then we can say cyclic E dot ds equals q enclosed by epsilon naught. So therefore the expression for E equals q enclosed 4 pi rho naught by 3 epsilon naught alpha 1 minus e to the power minus alpha r cube divided by 4 pi r square. So over here on solving we obtain the value of E as rho naught upon 3 epsilon naught alpha r square 1 minus e to the power minus alpha r cube. So this is the expression for E that we have, and the answer to the problem of the first part, which is asking us to calculate the magnitude of electric field strength as a function of r. Now for the next part, the problem is asking us to investigate the obtained expression for the small and large values of r. So if we investigate this result that we have obtained, so we can say for alpha r cube less than 1, So if this term alpha r cube is less than 1, so we can say e to the power minus alpha r cube can be approximated as 1 minus alpha r cube, and therefore the expression for e turns out to be rho naught r by 3 epsilon naught. Now over here in the second part, if we approximate the expression for alpha r cube greater than 1, so for alpha r cube greater than 1, e to the power minus alpha r cube will become equal to 0, and then we will be left with the expression of electric field strength as rho naught upon 3 epsilon naught alpha r square. So these are the two important deductions that we obtain on approximating these values to be less than 1 and greater than 1. And this is how we solve this problem 3.27.